this is another last. I hope you guys aren't tiring of hearing that because it's another last. I repeat, this is the final new instructional period of Algebra 1, the last one of the entire year. Now we do have our test review tomorrow on Tuesday, and then you take your test on Wednesday, and if you need to, Thursday, to finish it up. And then there's a project. If you haven't seen the class in English yet, you probably haven't. If you're following our normal schedule, then there is another assignment still for the rest of the year. This is the last video instructional period outside of our review tomorrow for the entire year, guys, in Algebra 1. So I'm excited about that. I know you're excited about it, but we're not done yet. Let's finish up strongly. We're dealing with Section 9 of Chapter 11. Chapter 11, Section 9. And we're going to finish up our whole new learning unit on radical functions, which means we're going to be graphing functions. I'm going to do this a little differently than what I have been. What I'm going to do, guys, is I have a graph, as you can see on the right side of the board, and we're going to solve a problem, quote unquote, and then we'll graph it, and then I'll erase that, okay? And then we'll solve the next one, and I'll graph it. And the reason is, if I tried to squeeze in a little tiny graph right here, it's just going to be a mess. So I blew it up where you can actually see it, and it might actually help you. Okay, so let's get right to it. We're going to be graphing radical functions. How do I do that? Well, hang on just a second. Let's tame our horses for just a moment, because I do need to tell you one thing before we get rolling. And that is that a radicand, which is the term underneath the square root symbol, the radicand, when simplified underneath the square root symbol, that's the radicand, it can never be negative. Remember that. Because the reason for that is that a term times itself can never be a negative. And so you can't have y equals the square root of negative x, okay, and have a correct answer. Because a term can never be negative underneath the square root, because there's no term times itself, whether it started out positive or negative, that will ever, under any circumstance, end up negative. So the radicand, or the term simplified underneath the square root, cannot be negative. And therefore, if you have, like we do in the first one, the square root of x, x must always be at least 0, because 0 is not a negative number, and therefore it can be 0, but it can only go up from that point if x is all by itself. Now, I don't want to make this confusing, okay, but it's just the reality, and we have to understand this. It is actually possible for an x under a square root to be negative, but it cannot be by itself. And some number has to be added to it so that when it's all said and done, it would get to at least 0 or above that, if that makes sense. And let me give you just a quick example. And we'll have one like this later, but I don't want to just say it and not show you, because it's not going to make any sense. But if I had, for instance, y equals x plus 3, and all that's the radicand, or all of it's underneath the square root symbol, actually I'm going to show you that in this case x actually could be negative 3, and here's why. If x is negative 3, what's negative 3 plus 3? Negative 3 plus 3 is 0, and see, you would have as your radicand 0, the square root of 0, and that's okay. You could have negative 2, okay, as a possibility for x, because negative 2 plus 3 equals 1, and the square root of 1 is 1. And so the radicand, when simplified, would be 0 or above. So you see how that makes sense, and again, we'll deal more with that in a minute. However, I did want to show you up front, it is possible for an x underneath the square root to be negative, but only if a number is being added to it that is at least that much or greater than what the negative number for x is. But again, we'll deal more with it. But for right now, in our purposes, the radicand cannot be negative, the term underneath when simplified, the square root. And therefore, if all that you have is just an x value, as the term underneath the square root, that x has to be at least 0 or greater, otherwise it's an undefined or it's a no solution answer. Okay, so we have y equals the square root of x. Now we remember from graphing linear equations, and that's what this is kind of, except it's a radical, but it's very similar. Guys, we can just plug in any values for x that we want. But remember, since all we have is the square root of x, we can't go any lower than 0. Because what's found underneath a square root has to be, when simplified, 0 or above. Well, I'm going to start easy, though, and I'm going to say I want x to be 0. Okay, well, let's see what happens in solving for y whenever x is 0. If I plug in 0 for x, what is the square root of 0? That's easy, isn't it? It's 0. So when simplified and I plug in 0 for x, then y equals what? Square root of 0 is 0. So my first point is going to be 0, 0. Let's plot 3 of these points for each one. Okay? Now I want to make sure that I choose things that when simplified, numbers that when simplified for x, are going to end up being perfect squares, okay? Because that makes it, or are perfect squares, so when they're simplified, they're whole numbers. Let me give you another example. A really simple one is I'm going to choose 1 for x, because what's the square root of 1? When I plug in 1 for x and I take the square root of 1, what does y equal? Square root of 1 is 1. Well, that's a really easy one also, isn't it? Now, as I move upward, and remember I can't go lower than 0 because that's all that's there is the x, and the radicand cannot be negative. I need to go up from there, but I'm not going to choose 2 because the square root of 2, when I take that, is going to be a decimalized number, and that's going to be complicated to graph. I don't want complicated in my graph, I want simple. Now, I'm going to choose for my next x value 4. And here's the reason I'm going to do that. The square root of 4 is an even number, which means that 4 is a perfect square, isn't it? What times itself gets you to 4? 2. So if I plug in for x 4 and I take the square root of it, what's y going to equal? 2. So those are my 3 points, guys, and that's all I need to graph it. I can put in any number I want as long as my radicand is when simplified greater than 0. I can do that, but I'm going to choose perfect squares to do that so that I have even numbers for my y value. Okay, let's plot these. 0, 0. Where's that on the graph? Oh, it's the origin, right? 0, 0. So that's where everything is going to start. All right? Where is 1, 1? 1 for my x, 1 for my y. I go over 1. And up 1. Okay? 4, 2. I go over 4. 1, 2, 3, 4. Up 2. 1, 2. Alright. Now look, my graph is going to look something like this. And that's not perfect, okay, but it gives an idea. It kind of goes up and then flattens out somewhat, but just barely continues to rise up. Now this is different than linear equations. Remember, it doesn't go below that point because that radicand simplified for x has to be 0 or above, and so it's going to begin there, and so I don't have an arrow on the other end like I do a linear equation. It's only an arrow on the end that ever so slightly continues to increase. And what's unique about these radical functions, whenever you graph them, is they're going to be limited on their x-axis. Okay, they're going to be limited on their x-axis. All right, now what I'm going to do, guys, is I will erase this. I'm going to fill back in what it is, the beauty here that I messed up. Okay, and now we're going to start on number 2. Okay, remember, the radicand, or everything that's underneath the square root symbol, when simplified, has to be at least 0 or greater. Has to be at least 0 or greater. So how do I figure whether that's the case, here's what I do. Watch me closely. I'm going to take just what's found underneath the square root symbol, x minus 3, and I'm going to write this equation, and I'll do this for every one of them. This isn't unique, okay? This is a formula. I'm going to write what's underneath it, x minus 3 without the square root symbol is greater than or equal to 0, because that has to be true for it to be a genuine function. Okay, and guys, from there I'm just going to solve. How do I solve x minus 3 is greater than or equal to 0? Well, that's easy. I isolate x, and the way I do that's by adding the 3 that's being subtracted. Add the 3 that's being subtracted. And I end up with x is greater than or equal to what? Positive 3. And so whenever I'm filling out my chart, and with each one of these, that's the place where I'm going to begin with that number. Because x cannot be any less than 3. Because look, if it were 2, I would have 2 minus 3. And when simplified, I'd have, find the square root of negative 1. Well, there is no such thing as a square root of negative 1. There's no number times itself that'll get you negative 1. It has to be positive, whether it starts as a positive or a negative number. Because if it's negative, a negative times a negative has to be a positive. You see why it's always a positive, no matter what? So I can start at 3, though, but only go up for my x value from there, because 3 minus 3, okay, I'm going to plug in 3 for x as my starting point. 3 minus 3 is what? 0. What's the square root of 0? Well, that would mean when x is 3, then y equals 0. Okay? Let's do our next number. And remember, in doing these, I want to make sure to choose numbers. I want to make sure to choose numbers that are going to just give me perfect squares so I have no decimals. I'm going to choose for my next one, eeny, meeny, miny, Espanol Cuatro. And here's where I'm going to do that. What's 4 minus 3? If x equals 4, and so I plug that into the equation, what's 4 minus 3? 1. Well, what's the square root of 1? That is going to be 1. So when x equals 4, and 4 minus 3 is 1, I take the square root of 1, I find y when x equals 4. Does that make sense? So when x is 4, y is going to be 1. Now I need to choose the third one. What one do you think I ought to choose here that's going to give me a perfect square? The next one up. I'm going to choose the number 7 for x, and here's why, guys. When I plug in 7 for x, I get 7 minus 3. What is 7 minus 3? 7 minus 3 is 4, and what's the square root of 4? 4 is a perfect square. That's why I chose 7, because I know in subtracting 3 from 7 that I'm going to get 4, and 4 is a perfect square. When I take the square root of a simplified 7 minus 3, which is 4, I get the number 2. Therefore, whenever x equals 7, plug it in, 7 minus 3, take the square root of the result, which is 4, that means y equals 2, because 2 times 2 gets me to 4. So my 3 points are 3, 0, 4, 1, and 7, 2. Let's go over to our graph, and let's plot each one of these. Okay, how do I plot 3, 0 as an ordered pair? I go over 1, 2, 3, and up 0, which means I stay right on the x-axis, but at 3. And that's going to be my starting point. 4, 1. I go over 1 more from the 3, so I'm at 4. I go up 1 this time, and that's my second point. I start at 7 on the x-axis, and I go up 2. So I was at, let's see, 1, 2, 3, 4. That's where I was. 5, 6, 7. Okay, 7. 1, 2, 3, 4, 5, 6, 7. And I go up 2. 1, 2. And those are my 3 points. That's all I need. I could do more than that, but why do more than we have to, right? And so my shape is going to begin at the lowest possible level for x, which is 3. And from there, I'm going to go up. And you can see it really levels off and it just barely increases then from that point on. And that is like what? That is like what a radical function looks. Okay, I'm going to pause, all right? I'm going to pause here and I'm going to put the other equations on the board and then we'll solve those. So here we are, back again. We're going to do numbers 3 and 4, and then I'm going to pause one more time for station identification. I'm going to pause once more to erase and put just a single one other one, number 5 on the board. Okay, so stay with me here. So our last lesson of new information, and this is new information, so we'll need to know this. Do stay with me to the end. Okay, so for our next one we have y equals the square root of x plus 4. Notice that's all that's under the square root, and minus 1 is by itself on an island on the outside. Okay, so what do I do to determine my starting point as far as the first one that I need to plug in as a possibility, the least number possible that could get me when the radicand is simplified to 0? Well, remember the way that I do that. I take what's underneath the square root symbol only, which means I don't touch the minus 1 out here. I just take what's underneath the square root symbol, which is x plus 4, and I set that equal to or greater than 0. Because whatever's underneath the square root symbol has to be at least 0 or beyond, but it cannot be beneath it. Okay, and then I just solve. Well, this is pretty simple because 4 is being added to x. I need to isolate x, so the way I do that is to subtract 4 from both sides. And so I end up with x is greater than or equal to negative 4. So look, x can actually be a negative in this instance. But its extent is negative 4 because we're adding 4, and that would get us to 0. But guys, that's going to be our starting point for our first x value, because that's going to be the limitation of the domain or the x value. And so because of that, I'm going to plug in negative 4 for my x. Okay? Now, whenever I put in, let's do this mentally, whenever I put in negative 4 for x, okay, what is negative 4 plus 4? What is negative 4 plus 4, or if you prefer 4 minus 4? It's 0. Or that way, 0. Makes no difference. Either way you look at it, 0. So what I have is y equals the square root of 0. Whenever we plug in negative 4, right, y equals the square root of 0, which we understand is 0. But then at the end I have a minus 1. So what is y going to equal when x is negative 4? Well, the square root of 0 is 0, minus 1 is negative 1. And therefore, when x is negative 4, I put that in and I solve for y, I have negative 1. Now, I know I wasn't writing those out on the last one, but it was easier whenever it was just one number. But when we're doing other numbers, it might help to write these out, and so I'll do that for each one of these because that's a little more complicated. So let's do that. What's the next one that we could do that would get us to a perfect square, which would be the number 1 for a term that we would put in for x? What's the next number that we could use for x? How about, guys, if I did the number negative 3? And the reason for that, look, what is, if I plug in negative 3 for x, what is negative 3 plus 4? Or 4 minus 3 is 1. And guys, 1 is a perfect square. And so that's why I use negative 3. It would get me to a perfect square under that square root symbol. So what's the square root of 1? That's 1. And then don't forget to subtract your 1, which is your equation on the end. What is 1 minus 1? Whenever you simplify the square root of 1, that's just 1. And 1 minus 1 is goose egg, 0. So whenever x equals negative 3, y equals 0. Okay, see how I'm doing that? And I'm just erasing because I have limited space. But you have more space. You can print each one of those out on your paper if if you want to do so. Alright, so what am I going to do next as far as choosing an x value that will get me to a perfect square? Well, moving up from there, I'm going to choose the number 0. And here's why I'm going to do that. When I plug in 0 for x, what as the radicand is 0 plus 4? What is 0? When I plug in 0 for x, what is 0 plus 4? That's 4. You see why I chose 0? That gives me a perfect square. What's the square root of 4? Well, that's 2. And when the square root of 4, which is 2, is simplified, what is 2 minus 1? 2 minus 1 is 1. It's pretty simple, isn't it? So when x equals 0 in this equation, then my y is going to equal 1. Okay, so let's move over to our graph and let's plot these 3 points, and then we'll do preschool work and draw our pretty line. Okay, -4, -1 as a point. I go over 4 to the left, that is, because it's negative. 1, 2, 3, 4. And then from there I go down 1, which is right here. -4, -1, my point is right there. -3, 0. I go over 3, but I stop there. I don't go up or down because my y is a 0 value. When my x is 0, my ordered pair is 0, 1. So I don't move on the x, and I go up 1. And so my points are right here, and right here. Preschool work, guys. I'm going to draw my lines. And so my graphed radical function is going to look something like that. I don't have perfect increments, and you're not going to either unless you're using graph paper, but that's certainly close enough, and it goes through our vital spots, and that gives you the shape of it. Just kind of a bent line. Remember, there's not an arrow on both ends, but this is the extent of the domain, -4, that we found from the very beginning. Okay, let me erase this, and then we will work on number 4. Redraw my lines just a little bit, make it slightly prettier. Not beautiful, but slightly pretty. Okay, there we go. Let's repair it anyway. When I have for number 4, when I have y equals the square root of -x, oh, ruh-roh, I can't ever have that, can I? Well, this is one of those tricky things, guys. There are rules, and there are exceptions to rules. In graphing this, we actually can do so, and really there's a sense in which, technically, yes, you can. And let me show you this, okay? On these graphing ones, graphing radical functions, do not write undefined or no solution, okay? Because there is actually a way, technically, that you can do so. And here's the way that's going to operate. Remember how I figure out what the extent or the limitation of the domain is? I set whatever's underneath the square root, -x in this case, equal to or greater than what number? Not a big one, but it is still a number nonetheless, 0. So whatever's the radicand, or underneath the square root, which is -x this time, I set it equal to or greater than 0. Now, how do I solve this? How do I solve this? I have a -x is greater than or equal to 0. How do I solve for x? Remember, when you see that negative sign in front of a term or a parentheses or a square root, whatever, whenever you see that in front of, it's implied that there's a 1 between that negative sign and whatever that term or that symbol is. So -x is actually -1x. How do I solve for x? These are being multiplied, -1 times x, and so I divide both sides by -1. Okay? And whenever I do that, because I divided an inequality by a negative number, what happens to my sign? It flips. And 0 divided by anything is still going to be 0. However, my sign flipped, and so what that's telling me is x is going to be less than, or it's going to be equal to 0. less than or equal to 0. So my starting point for x is going to be 0, okay? But then I just go down, not up, but this time I go down from that point. And I'll show you in just a second why it is that technically this works. All right, so what we're going to do is plug in 0 for x. Now obviously, guys, the square root of a negative 0 is still going to be what? 0, okay? So when I plug in 0 for x, obviously y is still going to be equal to 0 because the square root of 0 is 0. Okay, now let's go down though from that point. And I'm going to plug in, remember it can only be down, it can't be a number greater than in this case. So I'm going to do the very next one, which is negative 1, and here's why. Let me show you. I didn't do this on 1 and 2, but I showed you on 3, and I'm going to show you on this one too. Watch this. If I have a negative and then x, and x is a negative number, like negative 1, what happens when those two negative signs hit each other? Do you see why this actually works now? Because two negatives make a positive. And then you have the positive square root of a number. What's the positive square root of 1? 1. So when x is negative 1, because there's a negative underneath that square root symbol, y is going to equal, when simplified and you calculate it out, the number 1. That's kind of cool, isn't it? All right, let's try one more. The next number that we choose also needs to be a perfect square. So don't choose 2. 2 is not a perfect square. Don't choose 3. 3 is not a perfect square. Now again, those will actually work, but it's just you'll end up with a decimal and it's much more complicated than what it has to be. Instead, let's choose a number like 4, because we know that's a perfect square. But remember, we have to go down instead of up, so it's not just 4, but what kind of 4? There you go. It's a negative 4. And so I'm going to plug in times that negative that's already there and plug in for my x value, negative 4. Why does this work if there's a negative? Because a negative hits a negative. And when a negative hits a negative, it turns the number into a positive. And so I take the square root of 4, which is what? Dos. And therefore, whenever x equals negative 4, and I do that math, y is going to equal 2. Okay, let's plot where we are and what we're doing here. What is this graph going to look compared to the others? All right, so I have 0, 0 for my first point. Well, that's an easy one, isn't it? It's right smack dab in the origin. For my second one, I have negative 1, 1 as my ordered pair. Negative 1, x value first, left 1, and then up 1. Negative 1, 1 for my y. Okay, and then let's plot one more. Negative 4 for my x, and 2 for my y. Negative 4, 2 is an ordered pair. 1, 2, 3, 4, 1, 2, and so it's going to be somewhere right around in here. And so my graph is going to look like this. See what happens when there's a negative sign underneath that square root symbol? Then it's going to end up shooting to the left instead of what we're more accustomed, as we've seen when the graphs going to the right. Okay, that's numbers 3 and 4, guys. Again, thank you for your patience. Stay with me just for one more. We're going to do number 5. I'm going to erase, put number 5 on the board, and then we're donezo with new information for the whole school year. Alrighty, Roo homies, just one more. Number 5. Now remember, to find the extent, and really I mean the limitation or the starting point, okay, of the x value, and which is really is going to serve as like the origin for this semi-line, not arrows on both sides, but just on one, whichever direction it's growing. To do that, I just take the radicand, which is the term underneath the square root, which in this case is what? X. Now it's not negative x like before, because the negative is not inside the square root, so don't put that. And remember, at one point we had a -1 out here to the right. We didn't put that. only what's underneath the square root as the radicand. And so what I'm going to do is just put the x without the square root, remember. I'm just going to put the x greater to or equal, greater than I should say, or equal to 0. It has to be, when simplified, at least 0 or above. And this one's easy because I'm done. There's no movement, no calculation to do. So guess what? Like before, we get to start at 0. That makes things really simple. That's where the origin's going to be. So if I plug in 0, and you want me to write it up here, does that help? Or I'll do it down here since we have more space this time. Y equals negative, which is implied a -1, right? But a negative sign times whatever is found underneath. In this case, it's going to be 0. Well, what's the square root of 0 times a negative, or maybe better stated, -1? Well, anything times 0 is still going to be 0. So that's going to be our first point. Remember, for my next one, I can only go above 0, so I can't go in the negative direction. For this one, I have to go in the positive direction. And so I can't go in the negative, I have to go in the positive, right? And so I'm going to choose this time some number, and I'm going to pick a perfect square, so I only have good solid numbers with which I am working. Okay? Well, how about the one that's right above 0 that's perfect square? 1. And the reason for that is, I know 1's a perfect square because the square root of 1 is 1 when simplified. But once it's simplified as a 1, then I have to multiply it by that negative sign, or if you prefer a -1, which is really the meaning of it. What is -1 times 1? Because this is going to simplify to a 1, right? But what's -1 times? What is a -1 times +1? That equates to, I don't want to get up into my sign up here, 30 finger erase. +1 times 1, that equates to what? -1. Pretty simple, isn't it? And so when x is, there's a toy car coming at my feet. When x is a 1, then my y, it simplifies to a -1. Because the square root of 1 is 1, and then it's times a -1, which gives me a -1 for my y. Okay, let's do one more here, and then we'll be good as far as being able to graph then. Okay, what's my next perfect square up from 1? I've done perfect square 0, perfect square 1. What's my next one from that point? It's 4. When x equals 4, what does y equal? And I'll erase all of this here for right now. Alright, what is the square root of 4? When x equals 4, what is the square root of 4? That's 2. Don't forget though to multiply it by this negative sign, which is an implied -1. And so when simplified, we have still that -1 on the outside, times, what's the square root of 4 simplified? 2. Okay, and what is -1 times this simplified, which is 2, give me? -2. So, when x is 4, y is -2. What do you think? Does that all make sense? I hope so. Give me some feedback via messages or FaceTime or calls if it doesn't. Okay, I want to make sure that it does make sense. We can do some practice ones together if we need to. Alright, so all we're going to do for number 5, guys, is just plot the 3 points we've been given. 0, 0. That's one of those easy ones. Right smack dab in the origin. Getting kind of blocked there, but you can see where that is. Alright, 1, -1. Kicking the car around. I go over 1 and I go down 1. Alright, 1, -1. 4, -2. 4, -2. Go over 4 on the x-axis. 1, 2, 3, 4. Go down 2. Okay, and so since 0, 0 is my starting point, here is like what my line is going to look. And see how it's starting to kind of even off, but it continues to increase ever so slightly in that direction. All right, and that is graphing y equals negative square root of a positive x. Okay, guys, that's all that I have. There's no new learning to take place. All that's left, guys, is review. We'll do the test review tomorrow. We'll take the test on 2 days. I want to give you plenty of time for this. So we're going to do tests on Wednesday, and if necessary on Thursday, then get those tests to me. Make sure they're all turned in. Make sure all your quizzes are done. All your homework's turned in, because I'm going to put a deadline, guys, it'll be the end of probably this week. I'll see, okay, before I tell you 100% for sure. But get that stuff to me, and those quizzes, because remember, get them done, then correct them when I send them back to you. And as many times I'm allowing 100% corrections. I shouldn't, but I am allowing that right now. I know it's kind of a tough time, and I love you guys too. And get those corrected, because you can use those quizzes on your test just like you can use your notes that you've taken. Quiz 5, by the way, Quiz 5 is assigned today. You have that in your packet. Make sure that you get that done, get it to me. I'll grade it pronto, get it corrected and back to you. You'll make corrections, get it back to me, and we'll finish up your grades, guys. But that's all I have for math. That's all the new learning. Yay! Just review in our math final. All right, guys, finish up strongly, and just shoot me any messages if you have any trouble. I'll be talking to you soon.